Next is example 3.6. In this question, we can see the system subjected to 400 pounds of crates, hooked on point B and hooked at point C, then supported by strut of AD. So this is cable AB and this one is cable AC. So this system in equilibrium. We need to determine the magnitude of tension developed in each cable and force developed along the strut AD. First of all, please recall back example 2.15, where in that example we need to determine the position vector, and then after that we need to find the magnitude, and also remember the unit vector formula. We need that in this example. Next, we need to draw the free body diagram for this system. Subjected to the weight of 400 pounds of crate, it will create the force hook on position B and also force hook on point C. Then also force of FD supported at point A. Next, we need to determine the coordinate for our position, what is for point A, point B, point C, and point D. To do that, we need to identify the origin for this system, which is point 0, 0, 0. After that, we are able to identify coordinate for the others. For this question, we identify the origin point 0, 0 is at D, where at here. Also, the origin point can be at any point you wish, but you should able to imagine which is positive, which is negative direction from the origin. Once we identify D is our origin, which is point 0, 0, 0, then we can identify another point. For example, we take point B first. So from point D for our origin on X direction to go to point B, it needs to move 2 feet on negative x-axis, therefore negative 2 on x-axis. On y-axis for point B on the wall, therefore it's 0 on y-axis. Then on Z for point B is going up by 4 feet, that is positive z-axis, so the answer is 4. So the coordinate for B is negative 2, 0, 4. Repeat the same procedure for another point, so we can find what is coordinate for A, C. Once we identify our coordinate, we can find what is the position vector and its magnitude. Now let's find the position vector for FP. And for FP is from A to B, so position vector RAB. Once we get the position vector, we can calculate its magnitude. So position vector for RAB is B minus A. So negative 2 minus 0. So we get negative 2i. Then for J, 0 minus 6, so negative 6. Then for our K, 4 minus 2.5, so we get the answer 1.5. So we get our position vector, then we can calculate our magnitude. So the magnitude for RAB is 6.5 feet. Always remember, you have to write your units. And we go for our FC. So for RAC, point C minus point A. Once again, net 2 minus 0, so 2i. Then 0 minus 6, negative 6j. Then 5.5 minus 2.5, so 3k. Then we can get our magnitude for RAC, 7 feet. Then do the same for RAD. So magnitude for RAD is 6.5 feet. Also, don't forget the weight of crate, which is 400 pounds, and it's on z-axis, therefore on negative axis, so W is negative 400k. Then we have to establish the dot product for our forces. So for FB is FB RAB divided by its magnitude, so we get our FP. Then do for FC and FD. As we know, as stated earlier, is in equilibrium. Therefore, FB plus FC plus FD and d weight equal to 0. Also, remember the forces or the summation of Fx equal to 0, summation of Fy equal to 0, and summation of Fz equal to 0. Then, what is our summation of Fx? So, summation of Fx, refer back our dot product. So, here, from FB, negative 0.38, also 0.286. So that make our Fx. So this is for equation 1. Check for Fy. So here, negative 0.923, negative 0.857, then negative 0.923. So that's make for second equation. Do the same for Fz. So we have another equation. So we have 3 equations. So we have to solve it. By solving this simultaneous equation, we can get our FP, our FC, and our FD.